Consider once more our representation of S3, which permutes elements of 3 vectors. And now let's take a vector with 3 identical components and act on this with some element of S3. No matter which one, we will always get back the same vector because we're just permuting the elements. So that's true for all G in S3. So the space of these vectors with all identical components is invariant under this representation. So what's this space? Let's call it U1. It's a subspace of C3. Vectors. We can write this easier. It's just a span of 1, 1, 1 is invariant. Okay, and even better, we can find a complementary space to this one. It's also invariant. So consider vectors Z1, Z2, Z3 with the components summing to 0. Now again apply some element representation of some group element here. Again, any G in S3. So we get some new vector, let's say W1, W2, W3, and here we also have that the components of this vector W sum to 0 because we just permuted the elements. And this means that the space of all these vectors here with this condition, that's also invariant. Let's call this U2. So let's say Z1, Z2, Z3 in C3 with the property that the elements sum to 0 is also invariant. And now the whole space is a direct sum of these 2 invariant subspaces, because if you take any vector in C3, then just decompose it into something that is constant, same entry in each element, you just average the entries, and then something that has sum 0 of the elements. So moreover, the whole space C3 is a direct sum of U1 and U2. And we write, oh sorry, I should write direct sum here. And we write the same thing for the representations. So we write the representation gamma is the direct sum of a representation gamma 1 and a representation gamma 2, where gamma 1 lives on U1 and gamma 2 lives on U2. It's just the representations carried by these subspaces. So writing this here just means that we have this direct sum decomposition with each subspace carrying a representation. Now in this case there's even a little bit more to say. So this space here is 1-dimensional and this space is 2-dimensional, which we can clearly see. A 1-dimensional invariant subspace necessarily carries an irreducible representation. A 1-dimensional subspace just cannot contain a non-trivial invariant subspace. And then here in this case one can show that the representation gamma 2 is also an irrep. So what we achieved by this is we decomposed our representation gamma into a direct sum of irreps.